Chapter 2, Part 2, Alkyl Halides, Alcohols, Ethers, and Amines. So let's look at functional groups again. With functional groups, the hydrocarbons are our starting point. So all organic molecules are going to have hydrocarbons as the base, and functional groups are going to be things that are added on. This is going to include alkyl halides, alcohols, ethers, and amines. We also have aldehydes and ketones, which are carbonyl-containing compounds, and this is a word that we will explain a little later into the chapter. And then carboxylic acids, esters, and amides are also carbonyl-containing compounds. They are carboxylic acid derivatives, and nitriles. So let's start with alkyl halides. This is one of the simplest functional groups. They can also be called haloalkanes. So with an alkyl halide, you replace a hydrogen atom of the hydrocarbon with a halogen atom. The general formula for an alkyl halide is Rx, where X is any halogen. Alkyl halides can be further classified based on the substitution of the carbon to which the halogen is directly attached. So for example, this is an alkyl halide. This is bromoethane. So we have a 2-carbon piece and bromine is substituted onto there. And this is considered a primary alkyl halide. And the reason it's called primary is that the carbon that the bromine is attached to only has one bond to another carbon atom. Whereas if we look at 2-bromopropane, the carbon that has the bromine attached has bonds to 2 other carbons. So that makes it a secondary alkyl halide. This next one has a shorthand name of T-butyl bromide. It can also be called 2-bromo-2-methylpropane. And this is considered a tertiary alkyl halide. If you look at the carbon that the bromine is directly attached to, it has bonds to 3 other carbons, and so we call it tertiary. We can also have aromatic alkyl halides. We're not going to use the primary, secondary, tertiary when we talk about these. So this is an aryl or phenyl halide. In this case, you have iodine directly attached to a carbon atom on the benzene. You can also have a halogen directly attached to an alkene. This is called an alkenyl or vinyl halide. Our next functional group are alcohols. And this is when you have the hydroxyl group, which is OH, attached to an sp3 hybridized carbon atom. And this is really important, the sp3 hybridized carbon atom, because you will see the OH group in one other functional group. I also want to talk about the name hydroxyl real fast. In Gen Chem 2, you are used to talking about hydroxide, the anion. So notice that the formula of these is the same, right? It's an OH group, and this anion was called hydroxide. When the OH group is a substituent on a hydrocarbon, it is called the hydroxyl group. So YL is telling you that you are describing a piece of the molecule. It's kind of like making it an adjective. You're describing something. So for example, a carbon can have whatever else attached to it, but if it has the OH group attached to it, it is an alcohol, as long as this carbon remains sp3 hybridized. There are 2 ways to look at alcohols. You can consider them hydroxyl derivatives of an alkane, or you can look at them as an alkyl derivative of water. So what I mean by that is, if we look at ethane, which is a 2-carbon alkane, and we take this hydrogen and replace it with an OH group, we have now taken ethane and turned it into ethanol. Another way that you could look at this is you have water and you take one of the hydrogens off and replace it with a 2-carbon substituent, an ethyl group, and that's going to make ethanol as well. And the reason that I'm drawing these connections is that ethanol has a lot in common with water. The OH group is going to be acidic. This proton is acidic, and the oxygen with its 2 lone pairs can also act as a Lewis base. And we're going to talk about acids and bases a lot in chapter 3, but that has that in common with water. The hydrogen is also going to be capable of hydrogen bonding with itself and with other molecules, just like the hydrogens on water. This molecule is polar, with the electron density moving towards the oxygen, just like water. So alcohols have a lot in common with water, including their level of acidity as well. Their pKa values are very close together. And we're going to talk about pKa's in chapter 3 with acids and bases. Another thing to look at is the bond angle between the carbon, oxygen, and hydrogen on ethyl alcohol. The bond angle there is 109.5 degrees, which is pretty close to the angle on water, which is 104.5 degrees C. The oxygen in water is sp3 hybridized. The molecular geometry of water is usually called bent, but the electron pair geometry is tetrahedral. Alcohols use the same classification system as alkyl halides. So a primary alcohol means that the hydroxyl group is on a carbon that only has a bond to one other carbon atom. So for example, this is geraniol. This is a compound that's found in rose oil, citronella, geraniums, and lemons. Citronella and geraniums are actually in the same family. That was kind of a random fact, I guess. But this alcohol is attached to a carbon that is only attached to one other carbon. And it doesn't matter that this carbon chain has gotten pretty elaborate and has multiple bonds in it. The fact is that the hydroxyl group is on a primary carbon, and so this is a primary alcohol. Benzyl alcohol is also a primary alcohol. The oxygen is not directly attached to benzene. It is attached to this carbon, which is only attached to one other carbon atom. So that makes benzyl alcohol a primary alcohol. Secondary alcohols can be really simple, like 2-propanol here, or the other name for this is isopropanol, which a lot of you probably have, in your medicine cabinets. Isopropyl alcohol is used in first aid. But this is a secondary alcohol because the carbon that the hydroxyl group is attached to 2 other carbons. So that makes it secondary. And again, this can get kind of elaborate if we want it to. We can have the alcohol on a secondary carbon, and it doesn't matter that all the rest of this is, cyclic, or that's a little more elaborate than our isopropyl alcohol. It's still just a secondary alcohol, and they're going to have similar chemistry. This compound is menthol. This is found in peppermint oil. It's also used as a decongestant and analgesic. So if you have like Vicks Vapor Rub at home, which maybe a lot of people are using right now because allergy season is crazy, menthol is found in those compounds, in those products. A tertiary alcohol, such as butyl alcohol, the hydroxyl group is on a carbon that is attached to 1, 2, 3 other carbons. And then we also have phenol. Phenol is where the hydroxyl group is directly attached to benzene. Notice the difference between phenol and benzyl alcohol. There is no carbon separating the hydroxyl group from the benzene ring. Now this compound, norethindrone, is an oral contraceptive. I believe it's kind of a mimic of estrogen or very similar to it. Notice that we have a tertiary alcohol on here. This carbon is attached to a carbon that has 1, 2, 3 other carbons attached to it. And we also have a phenol. So you can have several different functional groups present in the same molecule. We also have an alkyne, and we have an aromatic ring. So there are 4 different things happening in this molecule. Okay, let's talk about ethers. Ethers are kind of a derivative of an alcohol. They have the general formula of ROR, meaning any carbons on this side and any carbons on this side. When you use R and R, that means that they could be the same. If you say R and R prime, you're saying that those two groups are different. It doesn't matter with ethers as long as the oxygen is attached to carbons. It is an ether. My organic 1 and 2 professor told me that there are carbons on either side of the oxygen. So if that helps you, I'm glad. Most ethers are non-reactive, so they are often used as solvents in organic reactions because they're unlikely to interfere and do their own reaction. So for example, dimethyl ether is used fairly often. Ethylene oxide, however, is highly reactive, and that's because even though this is an ether, because there's a carbon, oxygen, carbon situation happening, the bond between these 2 carbons forces this to be a 3-membered ring. And when we get to alkanes, we'll talk about why a 3-membered ring is not a great idea. There's also tetrahydrofuran, which is shorthanded as THF. This is also a cyclic ether, but since it is a 5-membered ring, and by 5-membered, I just mean that there are 5 things in the ring, right? So it's a pentagon shape. It's not reactive at all. It's very often used as a solvent, and so you'll see THF very frequently in this class. We also have amines. Amines are organic derivatives of ammonia. So if alcohols are derivatives of water, amines are derivatives of ammonia. So ammonia is NH3. Here's the structure. This is trigonal pyramidal molecular geometry. The electron pair geometry, however, is tetrahedral because the lone pair takes up its own space. Now these have their own classifying system. If you have a nitrogen that has 2 hydrogens and only 1 carbon attached to it, it's called a primary amine. If the nitrogen has 1 hydrogen and 2 carbons attached to it, it is called a secondary amine. If the nitrogen has 3 carbons attached to it, it is called a tertiary amine. So slightly different classification system from alcohols and alkyl halides. You can also have quaternary amines, but they are then called ammonium because they're going to have a positive charge on the nitrogen. So your inorganic molecules here, ammonia and ammonium, are directly related to their organic derivatives. Here's a good example of an amine. This is dopamine. This is a primary amine because the carbon that's attached to nitrogen is the only carbon attached to nitrogen. And then there are 2 hydrogens. So since nitrogen only has 1 bond to a carbon, it is a primary amine. We also have these 2 phenol groups over here. And when you have 2 phenol groups that are on adjacent carbons, it's called a catechol. And so this is a very specific subgroup of organic compounds called a catechol amine. And if you look into that, you get into all sorts of fun biomolecules. And then our last example here is nicotine. So nicotine has 2 different examples of amines. It has a tertiary amine that is also part of a cyclic structure, which is fine. This is a carbon, and so is this. So this is a tertiary amine. And then we also have an amine that is part of an aromatic system. So this is called a heterocyclic amine. And you'll see more of that in chapter 14 when you get to aromatic chemistry in organic 2. For now, you'll often see a molecule that is just this piece of this, and that's called pyridine. It's often used as a base in organic reactions.